Hello, this is Mrs. Ward, and I am going to go over the review worksheet for section 4.1, measures of angles and radians and degrees. So number one, as you can see, it's really not a question. It's just asking you that these are the formulas that you should know. You should know that a complementary angle are two angles, two positive angles that add up to 90 degrees. So to find a complementary angle, you're going to take the angle that you're given and subtract it from 90 degrees, or if you're in radians, you're going to subtract it from pi over 2. Two supplementary angles are two positive angles that add up to 180. So to find the supplementary angle, you're going to subtract your angle from 80 degrees, 180 degrees, sorry, or you're going to subtract it from pi. Remember, if you get a negative answer for either complementary or supplementary angles, that means it's not possible, which means you could not find a complementary angle or you cannot find a supplementary angle. Coterminal angles are two angles that end up at the same place. They have the same initial side, they have the same terminal side, but they just do either extra laps around the unit circle. So you either add or subtract 360 degrees when you're in degrees, or you add or subtract 2 pi when you're in radians. Remember, the 360 degrees and the 2 pi represents one lap around the unit circle. And the last formula is probably the only one that might be new or challenging, is the one where you have the arc length. Arc length is equal to S. S stands for the arc length. Is equal to the angle times the radius. Remember, when you're using this formula, that this angle has to be in radians. So if it gives it to you in degrees, you have to change it to radians first. All right, so let's start going over some of the examples. Number 2, actually determine what quadrant an angle lies in. So pi over 4 is actually a simple one because it's easy. It's no laps around the unit circle. All I'm going to do is remember when I have my what quadrants I'm in. This is 0, this is pi over 2, or 1/2 pi, this is pi, and this is 2 pi. So pi over 2 is less than 1/2, so that means it's going to lay somewhere in the first quadrant. If I have 4 pi over 7, that is not, I have to decide what quadrant it's in. If I want to, I know it's either going to be in the first or the second quadrant because 4/7 is less than 1. But if I'm not sure whether it's greater or less than 1/2, on your calculator, you can just take 4 divided by 7 and get a decimal, and you get 0.57, which means it's greater than 1/2, which means that this angle has to be here somewhere, which means this is going to be in the second quadrant. C is negative, so it's negative 3 pi over 4. So if I'm thinking about this would be 0, this would be negative pi over 2, because remember when you're going, a negative angle goes clockwise, this would be negative pi. Negative 3/4 is more than negative 1/2, but less than negative 1, so it's going to be here somewhere, so that's going to be in the third quadrant. Negative 11 pi over 6 is going to be the same idea. This will be, it's more than negative, it's negative 11, 6 is more than 1, so it's larger than negative pi. I need to know if it's larger than negative 3 pi over 2. So if I'm not sure, I would take 11 and divide it by 6 on my calculator and find that it's 1.8. So it would be negative 1.8. So this would be like a negative 1.5. So negative 1.8 would be here somewhere. This angle is going clockwise, and so this angle is going to be in the first quadrant. Okay, going on to number 3, determine two coterminal angles, one positive and one negative for pi over 4. So remember, coterminal angles are two angles that are different. They have the same initial side, they have the same terminal side, but they have an extra lap around the unit circle. So since this one's in radians, that means I'm going to add and subtract 2 pi. So I'm going to take pi over 4 and add 2 pi. And when I do that, I believe I get 9 pi over 4. And that's positive, so I'm happy with that. So that'll be my positive one. And then I'm going to take pi over 4, and now I'm going to go clockwise. So I'm going to subtract 2 pi. And when I do that, I get a negative 7 pi over 4. So I have one positive, one negative, so that question's done. For B, I have Negative 3 pi over 2, so I'm going to take negative 3 pi over 2, and I'm going to add 2 pi. And when I do that, I get a positive pi over 2. Negative 3 pi over 2 minus 2 pi, and when I do that, I get a negative 7 pi over 2. Just by adding and subtracting 2 pi, I get one positive and I get one negative. 84 degrees, now I'm in degrees, which means I am going to use 360 instead of 2 pi. So I'm going to take 84 plus 360, and these are both degrees. And when I do that, I get 444 degrees. And then I'm going to take 84 degrees and subtract 360. And when I do that, I get negative 276 degrees. Again, I ended up with one positive, one negative. Now I have negative 20, so I am going to take negative 20 in degrees. So I'm going to add 360 degrees, and I get positive 340 degrees. And then negative 20 degrees minus 360 degrees, I get negative 380 degrees. So one positive, one negative. Number 4, find the complement and supplement of each angle if possible. This if possible tells you that there may be times when it doesn't work, so keep an eye out for that. So if I have pi over 6 and I want to find the complement, remember I'm going to take pi over 2 and subtract pi over 6. And when I do that, I end up with pi over 3. So you're either making this 3 pi over 6 minus pi over 6 with a common denominator, and you get 2 pi over 6, which simplifies to pi over 3. If you're not a fan of fractions, which I still don't understand, you're going to take 1/2 minus 1/6 on your calculator. It's going to give you 1/3. You're just going to have to make sure you put pi in there. So that's the complement. It is positive, which means it exists, so that answer is okay. Now to find the supplement, I'm going to take pi and subtract pi over 6. And when I do that, I get 5 pi over 6. Because remember, this pi was understood to be 6 pi over 6, so I get 5 pi over 6. Okay, starting part B, I now have 5 pi over 3. So when I try and take pi over 2 minus 5 pi over 3, I end up with a negative, oh, what do I end up with? I end up with it ends up being negatives because this is, oh, I hate it when it's, okay, 3 pi over 6 minus 10 pi over 6. Yeah, so I end up with a negative 7 pi over 6, and that's negative, which means that does not work. And so it doesn't work, so that means there's no complement. Now I'm going to go ahead and try and find the supplement. So to find the supplement, I'm going to take pi and subtract 5 pi over 3. Well, I believe the same thing is going to happen. This 1 pi is 3 pi over 3 minus 5 pi over 3. And I get negative 2 pi over 3. That is also negative. So that's negative, negative, which means it's not possible, which means there's no supplement. And if I were to ask you this, which I could ask you this, but if I would have asked you this on a different part of the quiz or review sheet, this 5 pi over 3 is actually in the 4th quadrant, which means it's not going to have a complement or a supplement. Okay, 81 degrees. It's in degrees, so I'm going to take 90 minus 81. And I'm going to get 9 degrees. That's positive, so that's okay. That's my complement. I'm going to take 180 degrees minus 81 degrees. And I'm going to get 99 degrees, and that's going to be my supplement. Next one, I end up with, I have 190 minus 105, and I end up with a negative 15 degrees. That is negative. So I'm going to say that is not possible, which means I have no complement. And then I'm going to take 180 degrees and subtract 105 degrees and end up with 75 degrees, and that is my supplement. So that's how you are expected to know those formulas for complement and supplement. Change each angle from radian form from each angle to radian form. So they are in degrees and I want to change them to radians. So I'm going to take 150 degrees. Remember, it's 180 degrees to pi, but I want the 180 degrees to go, if this is in the numerator, then I want the 180 to go in the denominator, and then I'm going to put pi here. It's always going to be pi and 180. It's just a matter of which one is in the numerator, which one's in the denominator. So when I do this, the degree symbol simplifies, and so I'm going to be left with 150 pi over 180, and when I put that in lowest terms, I end up with 5 pi over 6. Part B is a negative 20 degrees. So when I have a negative 20 degrees, oh, different colors, who knew? So this will be negative 20 degrees over 1, and it's understood to be over 1. Again, the 180 degrees is going to go in the denominator. The pi will go in the numerator. That way I can see that the degree symbol simplifies. So I have negative 20 pi over 180. You can put this in your calculator and it'll give you a fraction in lowest terms. You just have to remember to bring that pi. So I'm going to have a negative pi over 9 as my final answer. Number 6 is asking me to change from the radian to the degrees. So I am going to take negative 7 pi over 6. I'm still using 180 degrees to pi, but since I want the pi to simplify, because there's pi in the numerator, I'm going to put pi in the denominator. 180 degrees will go in the numerator. So when I do that, my pi's will now simplify. Oh, that's really not a good color. My pi's will simplify, and then I'm going to end up with negative 7 times 180 over 6. And when I do all that, I believe I get negative 210 degrees. And then the next one, I have 3 pi. So I'm going to do 3 pi. That's understood to be over 1, multiplying by 180 degrees over pi. So the pi symbols will simplify. And I end up with 3 times 180. And I get 540 degrees. Number 7, it wants you to find the angle. So you have the picture below. This is where I'm using that formula that the arc length is equal to the radius or the angle times the radius. R theta, theta. I don't remember how we, well, either way. So this, when it gives me this symbol, that means it's the arc length. So this 32 is my arc length. The 7 is going to be the radius. So I'm going to have 7, and then I'm looking for my angle. I'm just going to divide both sides by 7, and I get 32 over 7 is equal to my angle. And I can just leave it like that, or I can change it like a decimal, but my units are going to be radians. So I'm willing to bet that, you know, this would be 3.14 radians, so it's going to be probably a 4-ish radians if I do that. So that's 7. And then the second one is says use the information below to find the angle. It's telling me, so I'm using the same formula, S is equal to theta times R. It's telling me the radius is 15, the arc length is 8, and I'm looking for the angle. So I'm going to divide 8 by 15, and my angle is going to be 8/15, so my final answer is 8/15 radians. Remember, that angle always has to be in radians. So if they give me the angle, I have to change it to radians before I can use it. And so this was an example of that one. So then now they're telling me that my angle is 180 degrees. They're telling me my radius is 14, and it wants me to find my arc length. So I'm still using that same formula. So now first thing I have to do is I have to change this 180 degrees to radians. So I'm going to say 180 degrees over 1. I'm going to use the 180 to pi. The whole 180 degrees will simplify, and so my angle in radians is just going to be pi. So I'm going to say the arc length is equal to pi times my radius, which they're telling me is 14. So my arc length is going to be 14 pi. Go up here, and whatever that unit is, that's your answer. Units for your answer. So my answer is going to be 14 pi inches, or I can multiply the 14 by 3.14 to get an approximation. The next one is the same thing. This time they're giving me the angle. It's already in radians, so I'm good to go. So I'm going to say S is equal to my angle, 2 pi over 3, times my radius, which is 27. When I multiply that, I do believe I get 18. 18 pi. And my units are meters. Okay, moving on to the next one.